Hello, geometry. You probably just got a lunch. Here, in fact, proving triangle congruence is a really big part of geometry, but these aren't as bad as that you think they will be. But we're going to be proving these, not by side, 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 like last section, but side, angle, side, and HL. HL stands for hypotenuse leg. So when you look at our learning targets, if we can prove by side, angle, side, HL, and solve real-world problems using those. So yeah, there's a big application part. All right, so let's do the warm-up. Okay, AM, that's this segment right here, bisects XY. So I know that this is going to be congruent to that. And AX, that's this segment, is congruent to this segment. Okay, so I need to prove that the top triangle is congruent to the bottom. Okay, so when my hand is there, it blocks it, so I got to be careful with that. All right, so here we go. First of all, let's put down our given info. AM bisects XY, and AX, these are segments, are congruent to AY. That's given. So far, so good. All right, I'm going to split these triangles apart. And then you should actually see what's happening. Okay, now this triangle we want to prove is congruent to this triangle. The top one is congruent to the bottom. And the only thing we've learned so far is side, side, side. So I have side, side, I'm missing the third side. And that's what this common one right here. Okay, and I told you that this would come up a lot in the beginning, but we'll get there. All right, first of all, I actually don't know that this segment's congruent to this one until I actually state what's happening here. AM is bisecting that segment XY, so that means XM is congruent to YM. And that's definition of a segment bisector. Okay, and then, now I'm going to go to this segment's congruent to itself. AM is congruent to AM. That's reflexive. Now, the top triangle is congruent to the bottom one by side, side, side. Triangle XAM is congruent to triangle YAM by side, side, side. Okay, so we should have gotten that down pat by last section. So here we go. A little bit of more new vocabulary. Do I need to turn that off? Let's see. Oh, that's probably a little bit better. Yeah, and I get less shade. Here we go. Consider the relationship involving two sides and the angle they form. That is called their included angle. Okay, that's this angle right here. So side AB and side BC make an included angle. We need that. Let me explain why. Postulate 20, side angle side congruence postulate says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So basically what you need is this side congruent to this side congruent to this side, and then their included angle. So we have side, angle, side. All right? So let's move on. Prove it. Okay, so complete the proof. Given AB is congruent to CB, so let's see here. AB is right here, is congruent to CB. That's going to be right here. And then DB bisects angle ABC. Okay, so that means we're going to get this. Now, what I'm missing is, if I split those two triangles apart, I have this, and this is the same sign, or same segment right here. And I will have a side, angle, side. So, let's get started. All right, here's my given information. then what's happening here? What does bisect mean? It's going to cut that angle in half. So this angle is congruent to that one. ABD, that's this one, is congruent to CBD. Why? Definition of angle bisector. Then, this segment, which is itself, BD is congruent to BD. What is that? Reflexive. And finally, is the top triangle congruent to the bottom one? Yes, it is, by side angle side. Alright? Hopefully you're getting the hang of this. Example 2. Slide that up. Oh, hopefully I fix this on your paper. Okay. In the diagram R, the center of the circle. Okay, so this is our radius, or our center of our circle, and that means this line, and this line are all congruent. Why? Because they're radii. A radius of a circle is all the same length. In fact, that's how a circle is defined. So, okay, so if SRT, that's this angle, is congruent to URT, that's this angle, what can you conclude about this top triangle, SRT, and the bottom triangle, URT? They are congruent. Why? Side angle side. Only because I know that all radii, I think that's how you spell radii, I don't know, are congruent. That's by side angle side. So technically, both of these are isosceles triangles. All right. So moving on. Okay, there's not much going on this page except I'm gonna break out a highlighter. Do I have a highlighter in here somewhere? Don't see a highlighter, so I'm just gonna use a red pen. Okay. Now, look at this. No side-side angle. Notice I didn't spell it backwards because then that could be an issue with some parents. In any case, if you know the lengths of two sides and the measure of the non-included angle, you can create two different triangles. So therefore, a side-side angle is not a valid method for proving triangle congruence. Because see this segment right here? What if I stretched it out this way? You still have the angle, the side, and this would be the same length. You do not get a unique triangle. So this is like, they call this the ambiguous case. You're going to see that in Algebra 2 and in pre-calculus when you are solving triangles using law of sines and law of cosines. So this does not work. However, there is a special case for if it's a right triangle, and it's called hypotenuse leg. Okay, so here we go. And again, this is the side-side angle that'll work if it's a right triangle and a right triangle only. Okay, hypotenuse leg, that's HL. The hypotenuse of one right triangle, okay, so it'd be here, is congruent to the hypotenuse of the other right triangle. Okay, and they're both right triangles. Then you have one additional leg. So if you'll notice, you'll have angle, side, side. And it's the only time you can have that angle, side, side, or we should say side, side angle, if it's hypotenuse leg, and you must, this is a requirement, have a right angle. Bad eye. Okay. Maybe decorate this, because if you don't have right angles, it's just not going to work. Okay. And you must have a right triangle, that's what's in the star, in order to use this theorem. If you have both of these requirements, then the triangles have congruent shapes. Okay? So, theorem, hypotenuse leg congruence theorem. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and leg of another triangle, then the triangles are congruent. Okay, so you must have a right triangle. And I want to emphasize that little box there. All right, let's use this stuff. Complete the proof. Okay, so I don't know if you can see this, A, X, Y, and M. So it's the same triangle that I showed you before. AM is perpendicular to XY, and what does that do? Perpendicular lines are going to give you right angles, okay? And then, so I know I'm going to get this. And then I have AX is congruent to AY, so that's all given. Now, what is this doing? Perpendicular lines will give us XMA and YMA right angles, okay? So perpendicular lines form 4 right angles. I know you're like, 4 right angles. If I extended this line, I would have a right angle here and here also. Okay, now, triangle XMA and YMA are right triangles, okay? Yeah, I have a right angle, but now this step I, find a little bit redundant, but if you have a right angle, then you have a right triangle. So it's the definition of a right triangle. Because remember, that was a requirement to do a hypotenuse leg. You must have right triangle. Okay, AM is congruent to AM. That's our side in the middle. That's reflexive. And that would be one of the legs. And if you're not sure what's happening, go ahead and split up your triangle. You have a right angle, hypotenuse, and a leg. So the top triangle is congruent to the bottom one by HL. Okay, we're almost done. Choose a postulate or theorem. Here we go. If you know that XA is congruent to YA, and XAM is congruent to YAM, what postulate or theorem can you conclude that the triangles are congruent? Don't forget we'd have the second one, the reflexive side. This would be side, angle, side. All right, going back to that because you might have forgotten it after we did the HL stuff. Here's our homework, our Common Core standard. Everyone have a nice afternoon.